Hello everyone and welcome to Mark Scheme Merchant. This video will be a quick overview of the halogens topic. Disproportionation will be covered in a separate video. Alright, let's dive into the topic. You'll be asked about 4 halogens usually: fluorine, chlorine, bromine and iodine. At room temperature, fluorine is a pale yellow gas, chlorine is a green gas, bromine is a red-brown liquid, and iodine is a grey solid. Moving on to boiling points, down group 7 the boiling points of the halogens increase due to the atoms being larger. The number of electrons increases as there are more electron shells. Induced dipole-dipole forces hold these molecules together. There are more or stronger induced dipole-dipole forces as you go down the group, which will therefore take more energy to overcome, so your boiling points will increase. Reactivity. The halogens are in group 7. They react by gaining an electron so they can have a full outer shell. In other words, they are reduced. Reactivity decreases down group 7. As you go down the group, the atomic radius increases, the number of shells also increases. This means you have more shielding. The electron shells act as a barrier between the nucleus and the outer shell electrons. So when you have more shells, the nuclear attraction will decrease. It gets harder to gain an electron down the group. That takes us on to displacement reactions. Chlorine will displace bromide and iodide ions, as it is more reactive than both. Bromine will displace iodide ions, and iodine is the least reactive of these three, so it won't react with either of the above ions. There will be no displacement reactions. Here's an example of an ionic equation for the displacement of bromide ions by chlorine. Displacement reaction colors. In water, when chlorine displaces bromide ions, the color changes from pale green to orange. When chlorine displaces iodide ions, the color changes from pale green to brown. When bromine displaces iodide ions, the color changes from orange to brown, which might be difficult to see. Using an organic solvent, it's much easier to see the displacement of iodide ions, as the colors are very different. When chlorine displaces bromide ions, the color changes from pale green to orange. When chlorine displaces iodide ions, the color changes from pale green to violet. When bromine displaces iodide ions, the color changes from orange to violet. Testing for halides using silver nitrate. Adding silver nitrate to a sample containing chloride ions gives you a white precipitate, with bromide ions will give you a cream precipitate, and if it contains iodide ions you will get a yellow precipitate. These colors may look very similar in practice, especially for a colorblind guy like me, so another thing you can do to identify what halide is present is dissolving these precipitates in ammonia. Silver chloride will dissolve in dilute ammonia. Silver bromide won't dissolve in dilute ammonia, but will dissolve in concentrated ammonia. Silver iodide won't dissolve in either dilute or concentrated ammonia. The precipitate will remain visible. Here are the ionic equations for the formation of these precipitates. And that's it. Nice quick video on halogens. If you found it helpful, give it a like, subscribe, and send this to your friends to help them out.